Hi, I'm Tomer Tan from Dell Technologies. In this demonstration video, I'm going to show you how to deploy CSM Replication for PowerScale and perform a failover of a Kubernetes application between two sites. CSM Replication is a module that allows provisioning of replicated volumes using Dell storage. In this release, we've added support for PowerScale using SyncIQ. This feature allows administrators to replicate groups of volumes using OneFS SyncIQ and provides an option to restart application in case of planned or unplanned migrations. For the purpose of this demo, I deployed two Kubernetes clusters, one in site A and the other one in site B. Each cluster is connected to a PowerScale cluster using the CSI driver. These PowerScale clusters are configured for replication using SyncIQ. If we navigate to OneFS, we can see that no replication policies are configured at the moment. We will use the CSM replication module to automatically create and configure them directly from Kubernetes. To protect our applications, all we have to do is to set the persistent volume claims to consume storage from the PowerScale replication storage class. In this demo, we will deploy a cloud-native application called Harbor Registry, which is an enterprise-class registry server that stores and distributes container images. To be able to access the same address from both sites in case of a DR scenario, we will use HAProxy as our load balancer with a static external public address. We use Helm command to deploy the application, and within a few seconds, all the application pods and PVCs are created. Using PowerScale replication storage class automatically creates the replication groups between the sites and starts the replication from the source to the target site. If we switch context to the target Kubernetes cluster, we can see that the replicated volumes are being created as persistent volumes at the remote site. Now, let's connect to Harbor Registry using the public address and add a new Docker image. We use the Docker push command at the source site to upload the image to the registry. If we refresh the library page, we can confirm that our new image has been uploaded successfully and is now stored in the source PowerScale cluster. By navigating to OneFS, we can see that a new replication policy with an RPO of 5 minutes has been created and assigned to the Kubernetes persistent volumes. Now that all the data is synchronized, I'm switching the context back to the source cluster and destroying the pods by scaling down the application to 0 replicas. By running the repctl get rg command, we can confirm that the data is now fully synchronized. We run the repctl failover command and specify the replication group that we want to failover and the target site. This process takes a few seconds to complete. In the meanwhile, we can switch context to site B. As we can see, all persistent volumes are now available. If we navigate to site B1FS, we can see that all the Kubernetes persistent volumes are now accessible at the remote cluster. At this stage, all we have to do is to deploy the Harbor application again at the remote site using Helm. During the deployment, Kubernetes automatically detects the replicated disks and mounts them to the pods. As you can see, within a few seconds, all pods are now up and running at the remote site, connected to the persistent volumes that contain the data from the source site. We can use the same public address to connect to Harbor UI. As you can see, the Docker image that we pushed is presented and available at the remote site. We can, of course, push another image at the remote site and confirm that it is reflected in Harbor user interface. By running the repctl get rg command, we can see that the status of the replication is failed over. To re-establish the replication between the sites, we run the reprotect command and specify the replication group and the new target site. This allows us to protect the data inside B, replicate the changes to site A, and of course, to restore the application data in case of planned or unplanned failover. I really hope you find this demo useful, and thank you very much for watching.